Rappin with ReefBum is sponsored by Polo Reef and Champion Lighting and Supply. Hey, welcome back, everybody. Welcome back to the show. My name is Keith, and with me is my co-host, Dong. Dong, how you doing tonight?
Very good, very good.
Anything,
my coral grows like nuts, so I'm happy.
That's a good problem to have. That's a good problem to have. I always say the same
yeah.
thing. I got the same problem, you know. I mean, that's better than the opposite, right?
Absolutely.
Oh, Chelly,
and
thank
just
you so
my
much
electricity
for that
bill
chat.
is not very pretty.
So what is?
Oh, the electricity bill. I just received my electricity bill 2 days ago. Oh my God. Well,
is that because
summer.
It's been the hot summer, right?
Yeah, I think it's the hot summer. The AC, the whole house AC is running. That's why.
You're running a lot of AC. Yeah, it's been pretty hot here in Vermont too. You know, I've been running a lot of AC. I've also got a dehumidifier that sometimes kind of will carry some of the load, but I had it set to a drain line configuration where it would drain into a a sump type of scenario where it would go into the drainage in the house or whatever, so I wouldn't have to constantly like empty the bucket on it. Well, that malfunctioned, and so I had to lean more heavily on the AC, and yeah, you know, that's also something that could cause a flood if your drain line malfunctions. Then you know, when I'm away, I run that thing, and thank God that didn't happen when I was away. You know, it's always something.
Yep, always something.
yeah. Oh, Greg, yeah, you're right. Dehumidifier is just an AC without the benefit of the cool air. That is correct.
That's correct.
I guess in Cali you don't really see too many dehumidifiers. I don't know. I would think that humidity is not a big issue out in the West Coast. So anyway, I think we're really excited, right, Dong, about tonight's show. We got an incredible panel. We're going to do a deep dive on coral nutrition with this panel. We've got Taras Pleskun, who is a phycologist at Top Shelf Aquatics. We have I love that title.
Yep.
We have Chad Clayton, who's the live feed supervisor at Aquaculture, which owns Reef Nutrition. Everybody's heard of Reef Nutrition. Phil Gilbert, who is the CEO of Polyp Lab, have him on the show, on the panel, and Ken Wingerter, who runs the microbial aquarium product company Hydrospace LLC. Ken Wingerter. I don't know if I didn't pronounce that correctly or not. I'm very conscientious of pronouncing last names correctly because my last name's a doozy. But before we have our guests on, I want to thank the sponsors who are supporting this show. They are very much appreciated. Polo Reef, make sure to check out Polo Reef's latest YouTube videos. Go behind the scenes with a day in the life at Polo Reef. See massive water changes, ICP testing, and giant pumps. Plus, lots of coral shipments packed with massive acro colonies. I'm going to have to check that out. And the excitement,
I need to see that.
Yeah, and the excitement of new rare fish arrivals, including a dragon pipefish and a groundbreaking, newly discovered species delivered for the first time ever in captivity. Make sure to subscribe to their YouTube channel at Polo Reef for video drop notifications. Champion Lighting and Supply. Flow is very important for keeping corals happy in a reef. That is absolutely for sure fact. Growing corals can block flow from wave makers and create dead spot. That's about to change. The ocean sea wave will oscillate any wave maker or power head in your aquarium from 0 to 180 degrees at an adjustable speed. This creates a natural dynamic flow patterns, reduces dead spots, and kicks up detritus. The ocean sea wave is available exclusively through Champion Lighting and Supply. Visit championlighting.com for more information. All right, I think it's time now to bring out our guests. So we've got Ken. Welcome there, Ken. We've got Phil, Taras, and Chad. What's happening there, fellas?
Hey, everybody.
Hi, everybody.
This is an all-star panel here.
Thank you very much.
Thank you.
Yeah. No, this is we're going to be rocking everything coral nutrition tonight.
Yep.
So thanks, folks, for joining us. I see a whole bunch of you in the chat. I see Amanda Meckley, Greg Carroll, Andrew Sandler. What's happening, everybody? Kelly, thank you again for that super chat. So, all right, there's a lot of stuff that we need to cover tonight, and I think we have plenty of jumping off points, but let's kind of like get into one that kind of comes top of mind to me, and that is, so we're talking about coral nutrition. What anybody can chime in on this one. What kind of signs can people look for in their corals in terms of whether or not they're being undernourished, malnutrition in corals? What are some of those telltale signs?
Pale color, low growth, for sure, and sometimes they react. They are really reactive with a lot of tentacles extension. I don't know the name in English to be exact, but with a lot of activity.
Or the polyp extension?
Yes, polyp extension for defense. You can see that they're struggling. That's one of the things, right?
Anybody else? Is that pretty much a good description in terms of what we should be looking for with corals that are malnutritious?
Well, when it comes to one other aspect, which is especially something, that I have my own facility now, but I don't want to speak too much for the specific coral farm that we have. But one issue everyone seems to encounter is nuisance algae, right? There's associations with various nuisance algae in ebbing of coral health. Now, I think it's kind of interesting because for the most part, we're talking about photosynthetic corals here. So we're not talking about just the health and nutrition of that cnidarian. It's actually, ironically, if we didn't have to have different things to feed them, MPS would probably be easier in many ways because you are just considering the health and nutrition of one animal, one digestive system. But instead, you're dealing with the photosynthetic coral, which is just the host, and now you have those zooxanthellae and then various other things that we know are associated. So the nutrition is not only that you're catering to, is not only to the coral, which more or less, I would imagine for a lot of these is catered to pretty significantly to a reasonable degree by those zooxanthellae, because we don't need to feed them as much as, let's say, an oyster for as much as they're growing by a long shot. But at the same time, the nutrition of that zooxanthellae is such a hard thing to tap into, because the nutrition are things that, we're trying to, it's very difficult to understand the nutrition of algae. It's not like we can just dose F/2 into the thing and then the zooxanthellae is going to be happy, the coral's going to be happy. You have to, there's some, when it comes to these photosynthetic corals, nutrition and environmental conditions are so intimately linked that it can be a little bit of a confounding question. Because I'm sure in theory, this may be super unhelpful, but just like with algae, like at the Noah Milford lab, we know that we can make a pure algae strain. It has no bacteria, no symbionts. Mark Dixon made it over in U Milford. It's for like laboratory experiments. So you need to know that T. isochryses did this. But without all those bacteria, it's just like having Bubble Boy, like the John Travolta movie. Like they don't have anything to, everything has something else to aid in its own nutrition. So in theory, we could probably make an acro that was completely devoid of its own zooxanthellae, and if we dosed in theory everything that zooxanthellae doses and change with that nuance, but it's you're not catering to just that, you're catering to the agent that moderates that. Makes this whole thing really complex, weird, and counterintuitive, and a moving target. And so yeah, if you have a bunch of pest algae, I could make the corals probably get pissed off and they die.
Well, Taras, you mentioned something, pests. How do we know whether or not it's pests that are pissing the corals off, coral pests, versus malnutrition versus trace element deficiencies? There's a whole bunch of different things that could potentially cause corals not to really, be fully representative of their health.
Here's something. I'm not a chemist. It's really not my thing. I'm trying to get better at like hardcore chemistry. But one of the things, I was working on an article for Ken, and it was about cobalamin. And it was one of those things where it's like, I don't necessarily understand it But just like with nitrite and other things, they're like species of these molecules, like different variances. And there's definitely different forms of the same thing. Like cobalamin can be utilized by a certain, like a cyanobacteria more efficiently than, let's say, like a eukaryotic cell, like our zooxanthellae. So there's probably different ways that I don't know who's doing or why, but it's different when things stabilize towards favoring a pest versus stabilizing the growth of like what we want and something that's very, very clean, and then things that are associated, like maybe coralline and the like. Maybe there's certain things that are setting the stage on a molecular level, and that is where really this, you know, I think the ICP and trace analysis, this is all going to be really, really useful, because I think that, you know, they're maybe setting the stage for this is the form of currency I use. And once cyanobacteria takes over, that's what's going to, you know, maybe there'll be a little bit so the coral can still grow, but, you know, we're going to start to dominate this. So maybe that part of that nutrition actually comes down to this, you know, the building blocks of what these photosynthetic critters are using in their nutrition in a specific way, and how they may or may not influence their local environment to have more of something that's more utilizable to them that we don't want versus what's utilizable to the zooxanthellae that we do want.
We're talking about an unbalanced system, which is easy to get in a closed circuit, right?
Mm. Yeah.
When it's unbalanced, you're going to have issues with either too many nutrients, the soup's not good enough, bacteria is not enough, some of the microorganisms not there, zooplankton, phytoplankton, everything needs to be in balance. Otherwise, you're just opening the door to newies and stuff. That's for sure.
And there's, yeah, I'm sorry, I don't want to.
Go ahead, man.
This is kind of a little off topic, but a little bit on the same as far as the setting the stage. This is one article I was looking at recently. It's for lobster farming, the European lobster, Hemeris gammarus. And they're doing comparisons on the larvae survival. And they're like, all right, we got these larvae. How do they do better with a basic question? Do they do better if we have a system that's quote unquote good? These are kind of questions I have to ask myself, like my Berkelhamer and stuff. Like, how clean do I want my water once I have a good thing going, right? Do you just do like the farmers of old, where you reproduce the good thing until you have, like, you know, magic compost? Or are we going to try and exercise absolute control? So what I mean by this paper that I found interesting is that they were doing these lobster studies with these larval lobsters, and those Rhodomonas and then Arcashatansa, the copepod, and they were testing the UV or not. And they were, when you had the UV, you had more opportunistic bacteria. That's what thrived, because the stage never got a chance to evolve towards things that were associated with what they considered more benign long-term inhabitants. So this nutrition also goes down to the things that we directly do to either shed, recruit, introduce, encourage the microbes that act as this intermittent. Yeah, there's this ecology that kind of crafts what resources hit the zooxanthellae, and then how that influences its need to be with that coral. God, all those targets, really smart people. I mean, I'm sure, but I think, yeah, there's that question of, like, you know, there's not, too much control could potentially eliminate a really, really good thing we don't necessarily understand, and that's really crucial to what we consider this nutrition of the holobiome.
That's what I was about to say. The microbiome, the holobiome, is really important, more than what we think. And the recent research to show that everything needs works in cooperation. So you're going to have those viruses, those bacteria, those zooxanthellae. You're going to have those fungi and fungi-like material, and also the nutriments that all have to work together in between each other with the corals, everybody in symbiosis. And that sometimes is a problem, because one of those guys not there, or one of those guys not happy. And I vulgarize it very, very much, very high level right now. But we need to take care of all these all together. And once one is in balance, the virus is going to take over, the bacteria is going to take over, and the fungi is going to get over. So it's going to take over. So that brings those algae, or those nuisance algae, to just populate and grow. That's one of the things we have been seeing in those recent research. But we've been looking at this since the 90s, and we just need to know what is for sure the organism that we need to reproduce into our closed system.
How do we do that, Phil?
big and rough job, because you bring live rocks into with your corals. You bring your corals with water from the wrong places. They're keeping some of that microbiome. We clean them up and we put them in tanks, right? Your soup needs, and I talk about the water, the tank water. Your soup needs to be in balance, needs to be controlled, as stable as possible. But how can you bring those microorganisms? Their repertory at 1.5 million different microorganisms in the 90s, only in the reef section, only in the reef setups. And today, with all the genomic research in advance, they have 2.5 million different types of bacteria and microorganisms in those same reef setups.
Mm-hmm.
How do you do it? Be my guest.
Just want to bring in a comment by Andrew here. Taras is directed to you. Aren't in theory, Taras, we better off feeding cultured zooxanthellae and zooplankton than phyto, where unclear coral takes up the phyto? Not saying feeding pods and lowest building blocks is bad, but
So I'm glad you're asking this. So I guess it was about a month ago now, I got a chance to go to the University of South Florida in Tampa, or just east of Tampa there. They have a zooxanthellae lab there. They're growing Aptasia, very small scale, but basically the whole point of the lab was kind of testing how zooxanthellae went in and out of Aptasia as like a model for corals. And I was going there, one, to learn about their Aptasia, shake hands, but two, I wanted to learn more about the zooxanthellae to explore that very question. Can I culture it? And to what extent can I offer it potentially as a food and then potentially as a therapeutic agent? So I talked to the lab and got a little bit of a crash course in zooxanthellae taxonomy, and it's a mess. But and then obviously, if anyone has any more nuanced information on this, I'd love to have some comments. But there's the class A, B's, and C's, at least as they refer it to me. And I don't want to get them in reverse order, but I believe it's class C's. They're the most general. So they're potentially the ones that I'll be able to culture and then maybe offer. They're the ones that are most commonly associated with Aptasia and things that kind of bounce in and out of symbiotic. They can exist kind of in the environment, be recruited as part of symbiosis, be shed, kind of do their thing. When you get into the other classes, the B's and the A's, I might have messed up the order. Forgive me. It's been a long day. That's when it gets very specific and very interesting. So that might be very specific to not only one specific species of Acropora, but perhaps even a particular individual or Acropora that's tenuous, that's exhibiting this specific epigenetic. It's living this way at this moment under these conditions. So there could be a very intimate way. So that could potentially be a therapeutic agent. I don't think that the hobby is anywhere near having that. That would not be a product that would be on the shelf. That would be something. So the only people I'm told of, there probably are a few others, but it's Ames in Australia that have succeeded in some pretty, I'm told, unconventional and for now proprietary approaches to culturing that. But as far as your overall question, yes, I can grow zooxanthellae. Yes, it can be used as a live feed. Yes, it may engage in some symbiosis with some inhabitants of the tank. It would be very unclear. But it would pretty much fall under the same general. It would pretty much fall under the same general recommendations as the other live phyto. It would be bred for its nutritional competency, and maybe the added caveat of it may engage in some symbiosis. But as far as something that would be dosed into a tank and I can look you in the eye and be like, it is going to bring a bleaching colony of, bubble bath unicorn back to life, that I think is still not impossible, but probably a few decades off. And it's with organisms that for now, I think only a few scientists have true privy to how they're growing and what they're doing.
I mean, the latter part of Andrew's question is, or are we just feeding our pods, not the coral? Chad, can you address that? I mean, in the sense of what you guys have in terms of products, is the intent to feed corals directly? Is it to feed pods. I know you guys have products that would enable you to dose that sort of thing. But what's your take on that in terms of is it feeding the pods, or are we directly feeding corals that's more important? And then Ken, I'd like to get your thoughts too in terms of what you guys do, which is the bacteria end of it all.
Yeah, I would say it's definitely going to be both. You're going to be feeding the corals and the zooplankton in a reef tank, and anything else that's filter feeding and grabbing particles out of the water column is definitely going to grab onto phytoplankton, microalgae, and consume it and gain nutrition from it. And a lot of the zooplankton that we work with in aquaculture is fed phytoplankton. That's basically what we're feeding to them to get them to grow and reproduce and have a good nutritional viability. So. Yeah, I think that's what that's what we've always told people, is that you're not just, feeding a filter feeder, a sponge, a bivalve, feather duster worm, things like that, but you're also feeding the zooplankton that are going to be in that system that are just, munching away on things all day long. And then you throw that food in and of course they're going to, get up there and grab it. So yeah, it definitely covers a lot of mouths, so to speak, when feeding phytoplankton.
Yeah, from a research paper I read, they said that coral basically just eat anything that can fit into their mouths, regardless what they are. They're just bacterial. Yeah, they're small. They fit in their mouths, and small zooplankton, phytoplankton. For matter of fact, there is one paper saying that they look inside the stomach of some LPS. I forgot what exactly species is, and there are zooplankton and phytoplankton inside. And they also did the same experiment on Acropora, and they found out mostly is type bacterial and zooplankton, but very little, if close to no phytoplankton at all. So I think that it depends on their mouth, the size of their mouth, then what kind of particle they can take in. So for Acropora, basically, I think the consensus so far on the scientific community is that you just eat anything you can fit in the mouth.
Even
no matter what. Huh?
Even microplastic.
Oh, yes, absolutely. Yeah, even microplastic. Yep. Anything that they just eat it if they can fit.
Here's a side question that I have. How do we know that we're feeding the right amount? I mean, obviously, you're looking for signs of the malnutrition, or if the corals are not growing, or if the corals are losing color. That's certainly one sign. But how do you kind of like dial that in? Do we basically dial it in by just kind of slowly ratcheting up the feeding? And stop when we start seeing problematic algae? Is that something? Or when the corals darken, is it that simple? Nobody wants to tackle that.
You got to test your water. You got to make tests on your water. You got to check. You got to check your parameter. I'm still today. I'm amazed at the quantity or the number of hobbies that are making or us vendor practice do not do water change. Maybe some people don't do them. It's okay, but actually don't know where it's heading, where it's going, in terms of nutrients, in terms of calcium, in terms of magnesium, in terms of very basic stuff, right? So one of the things that you need to make sure when you don't want to overfeed and you don't want to have too much of a product into a tank, a producer, a manufacturer can give a general rule of thumbs feeding advice, but the bioload of an aquarium is different all over the place. I mean, everybody has a unique aquarium and a different aquarium, so it's difficult for customer service to just answer the question as my corals doesn't seem to look good. I have algae issues. I have whatever. My nitrates are high. My phosphates are high. For some people, it works great. For other people, it doesn't work great. For some people, they have no phosphate. They have to add it. This is something amazing for me. There's stuff that they sell to have phosphate in your tank. But I mean, okay, it's fine. But
what happens like when you've got the algae and the algae is consuming the nutrients? How do you know what the corals need versus what's getting consumed by the algae.
You do a test and you see your nitrate is on the roof. You see your phosphate is on the roof. Your light is, you never change your light. Well, not today with the LED. In the past, the spectrum was an issue with the light spectrum with the HQI and NT5 were an issue. Today with LED, maybe it's no longer an issue, but light intensity, water flow, if your water is not flowing correctly, if you don't remove enough DOC from your tank, all of these are all factors that can bring to problems of unbalanced closed system. It's difficult to keep a closed system. The ocean's big, right? We can dilute almost everything, not anymore, right? We're polluting everything. But in a closed system, Taras was talking about complete control. Are we looking for complete control of the closed system we have, or are we just looking to make everybody happy and keep things in balance? So I would say that one of the big things about keeping a good tank or a tank in health and balance is to make tests and check your parameters.
And Ken, how much can hobbyists lean on your products, the bacteria products, to help control, consume the organic waste and help manage some of the nutrients? Is that one of the main use cases for your products?
Definitely, yeah. The results will vary, as they say, from tank to tank because every system is unique. So in many cases, for these bacteria to be able to proliferate and therefore assimilate nutrients and degrade organics and so forth, they need to be growing. But they need other things. That's their bread and butter, but they also may need certain trace elements, for example, that may or may not be present in sufficient quantities in one person's system or not, or even between dosing. So that all depends. But broadly, yes, these bacteria, and there's nothing unique about that with the particular microbes we sell. It'd be these just kind of a lot of live bacteria you might feed, and also live phytoplankton too, are going to pollute the water less, partly because they're just less polluting than processed foods are. But then also, so long as they're alive in the system, they might actually do their biology, in so doing take up a lot of nutrients, and if they're heterotrophs, degrade carbon. So it's going back to the question, what do we do? How do we know if we're feeding enough? Well, we have to make a decision. Are we going to cut back? Are we going to cut back on the feeding if we start to see pollution, or are we going to upgrade our filtration? A lot of times we'll just pull back on the feeding, right? But even with photosynthetic corals, feeding them actually really promotes health. So what they find, at least with wild corals, is that well-fed corals, the photosynthetic, so it's not like feeding and photosynthesis are exchangeable, right? For example, the zooxanthellae mainly produce carbon, but they need sources of phosphorus and nitrogen as well, and they get that from when you feed the coral, or in the wild when the coral feeds and releases the waste products, delivering them to the zooxanthellae. But at the risk of going on too long here, I could actually tie a lot of this in some parts of our previous discussion together with this. We're here talking about feeding, right? And it's like we're talking about this as being like an alternative to simply just putting light on them and waiting for the zooxanthellae to do some stuff, to feed the coral by itself. And that part of coral biology is pretty magical, right? But any coral biologist will tell you, the zooxanthellae are responsible mainly for producing carbon to the coral, a lot of sugars and things like that. But they still need sources of other things. That's why if a well-fed coral actually photosynthesizes better in the wild and presumably in an aquarium, because the coral's receiving all those other things it needs as well, the trace elements, not to mention the nitrogen and phosphorus that it needs. So if we're going to feed, I think even Phil would agree that live foods are going to be overall less messy and produce some other side benefits in sequestering nutrients, potentially degrading carbon waste and stuff like that, and then acting as probiotics. So that's and as I finish up here, I just point that out. That, there are two things when we're talking about these live foods. We're talking about them as explicitly being coral foods. The coral just eats it and, goes in and out of its manus, use an aquarium term. Or we can be talking about the probiotic effects, which are much more far-reaching than that. So, like what Taras said about vitamin B, there's a paper that just came out this year talking about a lot of the bacteria we grow, phototrophic probiotics of corals. They're not necessarily abundant in the coral. The coral isn't necessarily ingesting a ton of them, but in a lot of respects, they're keystone species within the coral holobiont because they have a disproportionately large influence on the coral's health. So, for example, they found that a lot of those probiotics are responsible for making cobalamin, which is, the vitamin B12, actually, that Taras brought up earlier. Not only the coral, but the zooxanthellae themselves cannot synthesize those substances. They have to get them from outside. They have to get them from their environment. And that's why these probiotics are so important. So when we're talking about live foods, we're often talking about a whole bunch of nutritional benefits that go far and beyond just them eating. It's all these probiotic benefits that go along, and presumably, even throughout the environment from the bottom up there too, talking about, and then I'll shut up. But the other thing was, talking about how, whether we're just feeding the corals directly or if we're feeding basically the whole ecosystem from the bottom up, right? When we add these primary consumers, the ecoplankton. Well, one interesting thing on coral reefs anyway is that on a lot of reefs that have been studied, one of the primary foods of corals are nanoflagellates. And we don't even talk about those or think about those or other protists in the aquarium industry yet. That's probably something we'll have to be looking at. But that doesn't necessarily mean we have to raise them and sell them in bottles, right? Because we may be able to sell appropriate bacteria or phytoplankton that they feed on. So if you add that to the water, those things naturally proliferate and then become food. Same with copepods that might be feeding on that phyto, and then they're consumed by the coral. So it kind of works its way all the way up the food chain. In some cases, carrying with it essential nutrients like fatty acids, carotenoids, and so forth. But it's far, like we've been trying to point out, far more complicated than it is to feed a fish. That's for sure.
Do we have any scientific papers, evidence that compares a coral taking something in directly versus a certain bacteria directly versus consuming something that's taken in, some bacteria product or some food? So I guess what I'm asking is live food. Well, it's a complicated thing, right? Because you've got corals are taking certain things in directly, they're taking certain things in indirectly. Then you've got live feeds versus concentrates. There's a whole bunch of different types of food. Do we have any scientific literature out there that kind of talks about that bang for the buck in terms of what you're going to get the most out of feeding your tank?
There is several scientific papers existing on the in the world about this subject. We have been tested in 2011 with other different type of foods as an external addition to corals in terms of growth. That's one thing, and I have just one in my face that's been done in 2025, really recent one. under which they cultured coral larvae, Acroporus larvae, and they've been able to demonstrate that by feeding them externally with brine shrimp, napoi, grounded to get them very small in micron size. The result was that those with heavy feeding were able to move farther away in settlement space, in size, and in survivable rate. I can share this research if you want later on, no problem. And it was live food but blended, right? But it was live food, blended live food. Research made in Australia, very 2025. So we're getting in there. You need to feed those animals in very different way. Of course, the bacteria will need something to feed on, whether it's nitrate, phosphate, or stuff that are in the water. Live animals, it's just they're going to be eaten by corals, but they're going to eat a lot of stuff too, right? And truly they're live animals, so it's a super option. You need to be able to see as well the fungi development around the corals, which supply some tryptoid and some very specific compounds for those corals to be able to survive in their environment. But there is research about external feeding that exists, a lot of them. It's just that it's not so specific that you cannot take one research and just say, listen, we know external feeding is good, whatever way you want to do it. It's very good for all types of coral except a pure photosynthetic one. But at the end of the day, since a long time ago, we know that external feeding is good. Now we're coming to the microbiomes, the bacteria, the viruses that's populate all around those corals, the fungi, and all those different docks that are around. That's what we need to master. I don't think that we're going to find a bacteria that's going to do all that job. That's why it's very complicated.
So complicated.
Yeah.
Hey, Chad, do you guys have any position in terms of the effectiveness? Any anecdotal evidence or any studies you guys have done in terms of live feeds versus concentrates?
There's nothing really out there because a lot of people just use our concentrates versus anything live when it comes to coral foods. Just because corals are fairly opportunistic and it doesn't need to be alive for them to consume it and gain nutrition. And so, there's not a lot of comparative studies out there with, in between some of our live versus concentrated, dead animal products and things. So,
if I could, this is kind of, I just want to take this opportunity because I do live feeds, so I wanted to kind of say why I like it so much. It's twofold, and because live feeds in my mind are two things, especially in this hobby/industry. They're a product, right? We buy it, we put it in our tank as a food, a live food. Product is supposed to have certain nutritional composition. Take that. We deal with both here at Calypso. We grow the same animals, same way, but they're both. Well, first route is the general, the product, feeding the whole reef. Now, we know that there are all these different diverse mechanisms of which various different things feed, right? Like we'll take some dramatic examples real quick. Like abalone larvae don't eat. They can absorb amino acids. So those can just, if you dose amino acids, argument for that. All the way up towards things that are specifically adept at eating specific bacteria, specific things down to the nanometerage, the size, the way they smell. The oyster can take in a lot of things, reject most of them, et cetera, et cetera. So as a whole, the idea of the product is that as a whole, because it's dangerous to overgeneralize in this hobby, we are looking for diversity. We want more diversity at almost every level without one particular organism being a pest, something that's destroying something we like. It's great. So we all can agree on that for the most part. And I hate to say this because I only offer so much of these products, but to the generalist, to someone trying to blind shot encourage as much diversity as possible, a myriad of different feedings is probably the way to go. Everything up from liquid inert feeds, amino acids, to powdered feeds that have specific, it's just the actual proteins, and like you want to have something actually eat it and digest it that day, and then going up towards live organisms that can operate as actual agents in the aquarium as part of the microbiome, or things that at least don't perish, that they are eaten by things that will only eat live feeds, live things. And for a lot of these organisms that we only recognize as some trade name, and it's very difficult to find papers on a lot of this stuff. I would say in order to encourage as a whole diversity, feeding the most stuff of good nutritional content, good fats, pretty much where all this stuff, good carotenoids, whatever shape or form you can get it, is the way to go. Now, specifically, the second way is as a tool, because I think there's two branches of this industry already forming. There's those that are keeping reef tanks that love them as works of art, and it's their passion, and they love and enjoy it. And I think there's this other branch that's also very exciting and valid, but they're the ones that the freshwater hobby has already had and catered. They're the home breeders. They're the people that are figuring this stuff out. They're breeding angelfish for the first time in their basement. They're breeding sexy shrimp. They're breeding animals that don't even have Latin names, most likely. For that end, having a lot of these things as tools, the idea that you are buying a live Isochrysys lutea to do with as you will. You don't have to necessarily pay $400 for a lab grade specimen. You're not going to do peer reviewed study on this, but you want Isochrysys so that if you're trying to feed something intentionally as a tool, you're trying to buy this copepod to feed it intentionally as something as a tool. I think that's where live feeds enters a new level of nuance, because although there are some formulated products that can be fed to larvae, there are far more for freshwater things that are just bigger when they're babies than there are the saltwater larvae that it's been very difficult to feed. So, and one last thing before I'll shush is that I got a chance to go down to the University of Florida Ruskin lab where they bred the hippo tang, and they didn't have them there, but over at the Indian River facility, which I'd like to go visit, I'm told they have the ciliates, which is like a new live feed, right? The idea of ciliates, right? We always think ciliates is a pest, but apparently they're going to be the new thing that are a little counterintuitive to grow right now, but they're going to be an attractive alternative to some of these pelagic coponopoly, if not maybe being able to feed things that we haven't had success with those yet. So live feeds are exciting because they add more to that product. They add more particle size, more smells, more sounds, more nutritional profiles, and can complicate all that because they're alive and the other bacteria. But they also are these specific tools that are allowing our hobby to do things that science thought was poppycock 50 years ago. Like, you can't breed angelfish in a basement in Sheboygan. Yes, you can. You can do it now. You just need some Parvocalanus and some T-iso and some Catosphorus would be nice, and you're ready to go. I've had it.
So I asked the audience a question. I asked the question, what do you feed your corals? And Paul, Great Beard of Reef, came up with this answer. Now, this was going to be a question of mine. This was something that I used to say all the time back in the day, that I don't feed anything to my corals. I just let my fish poop do the job, and the more fish you have, the better. Is that a valid thing to say these days? Well, if you have a big population of fish, will the fish poop be enough, or will that be deficient in nutrition? I mean, it's hard to answer that question, I guess, because I'm sure there's no scientific studies that have been done in terms of whether or not a tank that relies solely on fish poop for coral nutrition is more successful versus a tank that's using some live feeds or some other type of coral fish food. But what do you guys think on the panel there about this theory that fish poop is enough?
I'm about to say something stupid, but go ahead.
I would just counter that with a question. Would you eat poop?
Well,
what is poop? Poop is waste. The fish have already
tacos,
extracted much of the useful nutrition from what they ate, and now it's nutritionally bereft for the corals.
So it's a pass through.
It's not as nutritious because it's already passed through an animal's gut and been digested, and it's literal waste. And also there are microbes sometimes in fish waste that can actually be harmful to corals. So that's unavoidable because fish are just going to poop in the tank. But to rely on that as a sole source of coral food, I mean, there could be instances, some corals, some types of fish, depending on their diet, things like that, where it may be beneficial, but I haven't seen any papers looking
Fish
into
poop
this.
is economical,
That
though.
one's good.
Yeah,
We like that.
Depends what you feed them. That's what I would like to say. I mean, what goes out, what goes in, what goes out, and humans, what we eat sometimes goes out good and sometimes doesn't, right? So it depends what.
Dong, all right, Dong, you got
Yeah,
some,
I think that's a very good, interesting question about the fish poop. So there is a different aspect of what come out from a fish, especially saltwater fish, and what come out from a maybe like an animal, because a fish has a really short digesting tract. So basically, I saw some scientific papers indicating that actually fish poop actually quite nutritious for the coral, not for human. So what happened is basically they very similar to the nutritional profile as the fish pellet or whatever frozen food you feed to the fish, because the fish actually is a very poor nutrient extractor. What the fish poop actually do is by grinding all these pellets, dry food, frozen food into micro powders. So you actually allow the coral be able to intake those particles because they're small enough. There's papers about in the ocean that about how important about the fish pooping and peeing to fertilize the coral, and try to answer that Darwin, what was that? I forget that word. So basically, why in the ocean the nutrition is so poor, but then coral grows so well. But in reality, on the reef, the nutrition is not poor at all. In the open ocean where a shamu swim, that is probably pretty poor. But on the coral reef, the nutrition level is really rich. But they are encapsulated form instead of like free floating phosphate and nitrate. So when they test the phosphate and nitrate, they're always low to non-existence. But the nutrition is packed into these little particles of fish poops and fish peas. And fish peas basically just like a liquid food that fertilizing the coral. So as I think there is a pretty good consensus about the scientific literature is about coral. Basically, they don't really differentiate or whatever it is. It's just whatever fit in their mouths. So I
so
remember
the garbage feeder. Is that what you're saying, Dong?
Yes, exactly. Yeah, anything. They just take in anything. So I remember there is a paper describing on the coral reef how the coral get the nutrition, and is that a group of fish fly by and then just running down poops and peas, but then come out with another interesting hypothesis is that the coral are feeding on occasionally. It's not constantly. For example, it's not like with those phosphate and nitrate to keep a certain level. That doesn't work. That's not coral. That's what that is not what coral are get used to be fit to be fed. Coral are used to be a cloud of fish fly by, boom. It's a huge amount of thing dump down on them, and then the water is very clean again. And then comes another rainstorm of peas and poops. And that is how the coral get used to and take advantage of that to eat that. But of course, the bacteria is one of the really the major life food that actually coral takes in. I think that my question for the panel is that because it's such a complex system, when we want to feed our coral live food, it actually probably most feasible way is the planktons, live phytoplankton, the live one, and bacterial. Otherwise, it's really hard to or impossible to get other type of zooplankton in that's alive to feed to our tank. I don't see a product like that on the market. I think that even if a product like that on the market must be really expensive. But bacteria is inexpensive to produce, inexpensive to ship. So I think that maybe is a good way to do it. And of course, like Reef Nutrition about the prepared food, I think those are especially in liquid form, those are great products. So because of that, it's all about particle size. That's my understanding is that, and liquid even better. So there is remember that paper about the fish sauce? They actually use newly hatched brine shrimp as live food to feed the coral, as well as prepared dry coral food. So it seems like coral is not picky, because the coral reef is actually a nutrient poor. Basically, beggars have no choice. Whatever comes along, and they evolve in the way that to grab any opportunity that ran on them, regardless it's poop, dry phytoplankton, reef roy. Yeah, because I saw that video that you guys actually feed the reef roy into the natural reef. Well, they grab it, they eat it. So yeah, so basically,
yeah, that was more of a stunt stuff, because
but it's true though.
I mean, it's true. And Jake Adams did that video, but it was cool. But the reality is that we're not gonna save the planet with that kind of stuff.
That would be a very expensive way to do it.
No, it's not gonna work.
This is an interesting comment from Frugal Reefer John, and I kind of alluded to it. Well, I guess Paul alluded to it with the fish poop comment, and I kind of concurred. But yeah, the comment here is, in the early days, reefers just concentrated on good light and good flow, good water quality, keeping the fish well fed, and everything grew and thrived. How did coral nutrition get so complicated? Is it because we have more information now?
Yeah.
Yes.
Of course.
Mm-hmm. Yep.
Yeah.
I think one of the interesting things, bringing up the last question, is, well, you're feeding your corals. You're just feeding them what you're feeding your fish. That interaction, I think, cannot be really ignored there. What you're feeding your fish is entering your tank.
Mm-hmm.
Depending on what fish you're doing, its intestinal system could be extremely long, like a vegetarian, like a tang, or it should be very short, like a grouper, big cardiac stomach. So there's all kinds of different microbes that can and will be shed from the feces of those different animals, and they're also leftover feed and their other exudates. There's a few. I wish I had the specific video in front of me. I'll maybe share it. But I know there was one comparative study I'd love to do in an aquaculture setting, where they were doing different populations. Don't quote me. I think powder brown tangs, and it was ones that were feeding predominantly a detritivore diet versus ones that were going full vegetarian. And what was the microbes that were coming out of their feces were wildly different. And those microbes were not necessarily somewhere associated with beneficial populations in corals. Others maybe not so much. So that interaction between fish diet is very that really can't be ignored. Especially in the Philippines, I did a little bit of training, and they take this kind of to crazy anecdotal levels, where they will stock tilapia in their Vaname shrimp ponds beforehand, because they figured this out later scientifically. The tilapia were shedding a bacteria that was kicking Vibrio's butt. And Vibrio will cost them their shirts with a shrimp harvest, especially if it gets really hot. So there are definitely different ways to understand this, observe it, and then strategize with it for sure.
So I just wanted to show a comment from Amanda Meckley. She's giving a shout out to three of the panelists here in terms of their products. Goniapora love Oyster Feast, Acanthophilia love Reef Roids, and Gorgonians love PNS. Disclaimer, no formal studies have been done on how much they love it. That begs a question for me. Is there a catch-all feed, coral food, or do we have to feed a lot of, different types of foods to satisfy different corals?
That answer was answered by Taras earlier on. You got to mix all those different kind of food, of weight, or particulates, or and all together, maybe not out at the same time, but over the time, over your standard practice. And I believe Taras answered that question very, very well. Everything is intricate into one thing, but everything is so needing everything else. It's kind of you cannot have a one. I would love to have it. I mean, myself, and I'm sure Chad as well, Taras as well. Everybody would love to have such a product, but it's not. I don't think it exists. I think it's a balance and everything else. And Taras is right in a great way, and in the fact that you should have something that represent a lot of different feeds to make sure everything's in balance.
Here's an interesting comment. I'm going to mispronounce this name, but Stephen, I'm not going to attempt the last name. Dunzer, maybe?
Dunza.
There you go. Live Rock is one thing that has changed between then and now. He's talking about kind of like back in the day with massively more efficient mechanical filtration. So, yeah, we have skimmers that are very much more efficient, have a lot of more capability to pull out stuff in our tanks. Is that something that is a consideration for the modern day reefer? Is that we're filtering out too much stuff in our tanks in terms of what feeding the corals, and that perhaps we need to be more cognizant of what we're feeding and we have to feed more stuff? Is the equipment today just too efficient? And that's potentially one reason why we're seeing some, issues with corals not having enough food. I don't know.
Yeah, I think it comes down to the hobbyist. I mean, and how dedicated they are. I know some people that have gigantic skimmers on small tanks, and they love to feed, and they will just throw in buckets of food, and I'm just blown away. I'm just like, how is anything alive? And then you get people that, prefer to have a skimmer only run 30 minutes a day and feed very small amounts multiple times a day. And maybe they have a dosing system set up. And so it's all about kind of looking at your tank in almost a scientific way and studying it and taking notes and making sure you're on top of things. And when you add something new, pay closer attention.
It's a lot of stuff, but when you have kids, a wife, and a house, and you have no, it's a lot of work. But it could be an interesting topic in the future to see, because it's a little bit the same question with activated carbon. There's a school of thought where people will use activated carbon all the time, but over the last years, people are using. I'm from the school where we're not using activated carbon all the time, only when we want to have the water polished, because it doesn't remove the DOC that might be important for bacteria and for other animals in the tank. So that could be a nice topics next with specialists with carbon. I'm not.
Let's dig a little bit deeper into that, Phil. There. So I've always used activated carbon 24/7. So are you saying that there's certain times of the day that it might be prudent not to use that activated carbon?
Absolutely. I really believe that using activated carbon should be part of as like a water change. It should be something you do once a week. Even when you start seeing your water getting a little bit discolored or yellow in colors, your tests showing high DOC, not IDOC, but some parameters you don't like. Carbon is activated carbon is going to remove a lot of stuff from the water that can be beneficial for your actual aquarium, for your soup. It's great. We need to use it, but I would never use it 24/7. On a tank, just for the sake of keeping a good microfauna and a good bacteria population.
Does everybody agree on the panel? Different opinions?
I actually stopped using activated carbon all the time now. I used to run 24/7, but I stopped that. I found that the coral grows a lot better without a 24/7 activated carbon. But if there's something happen, for example, if I look at my water change bucket, it looks freaking yellow. Yeah, then I run a bag of activated carbon because the activated carbon only good for a very short period of time. So I just run it overnight, take out the bag and toss it, but I don't replace it until next time I look at my bucket. Oh, so disgusting! And then I
But let's say you have a treatment to do to the tank, flatworms, whatever, animals or something in the tank happens, and you have to use a an antibiotics in the U.S.
Yeah, yeah.
You must use activated carbon after to remove this kind
Yes.
of compounds that can be detrimental to your tank.
Mhm.
That's what I believe. It's a new school of thought, maybe but I think that more and more people will go to this way to keep the microbiome intact and give them as much stuff as possible to grow.
Yeah, I think DOC actually is not all bad. Actually, DOC is very critical. Yeah, because the bacteria feeding on DOC. Actually, the one scientific paper basically saying that the whole coral reef is running on DOC. That is the fuel for the coral reef. So and it's really hard. Of course, there's a bad DOC, but that we call them pollution. But most of the DOC are all utilized by different type of living organism, and yeah, I think that and also of course the activated carbon. My major concern is that a poorly made activated carbon, which has a lot of dust, it definitely affect my fish. So that is another concern, and also that they're so expensive these days. Do you guys notice that how expensive activated carbon these days? Oh my goodness, the good ones are so expensive.
But what the problem is, it's not really the problems of the material itself. It's the problems of having it to be shipped. It's considered as a dangerous goods now, and it's just
really
rising the cost of shipping like absolutely crazy. And the regulation has been tightened up on activated carbon pretty much all over the world.
Ken, what do you think about the use of activated carbon? Is that something that you recommend people don't do using your products?
I think it would depend a lot on the application. So say you have a giant algae scrubber or something like that, it might actually be required. It's just a part of that means of nutrient removal to get rid of all the exudates from the algae. They tend to be most harmful to corals. So not all DOC is the same. In a healthy reef, most of the DOC will be derived from corals, specifically coral mucus, whereas on a damaged reef, a polluted reef, we'll often see most of that DOC will be derived from algae, algal exudates, which are very different. In some cases, they don't even really affect the microbiome, but they do. But the bacteria that are there process them differently. They consume them differently in such a way that they either become virulent, or in a lot of cases, they simply just they consume it so quickly that they respire. The respiration rate goes up, and then they deplete very locally oxygen levels near the coral, and that's been shown to cause tissue necrosis in corals. But that's specifically caused by algal exudates, that form of DOC. So they're definitely different. The types of DOC produced by corals, you don't see that. And in fact, that those particular sources of carbon promote the growth of more desirable, in terms of coral health, more desirable organisms. So
yeah, I think that on top of that, there's a scientific paper back up what you said. So basically, even on YouTube, you can find this experiment. I think it is performed by a professor from University of California, something like that. So they have a tank. So there's a membrane in between. The membrane won't allow the bacteria to pass through, but allow small molecule, the DOC, to go through the membranes. One side has, to make it very simple, is one side has macroalgae, the other side has aquapora. So what happened is that what they found out is that the macroalgae actually release certain DOC. Then the DOC pass through the membranes, and then those DOC will stimulate those bad bacteria that can actually harm the coral, that cause the coral to recede and die. And that's one of the mechanisms the macroalgae take over the reef. It's like form of chemical warfare by excreting DOC. Just like you said, that those DOC is produced by algae. The goal is to stimulate the growth of bad bacteria to harm the coral, and then they take over the space. So I think that you're absolutely correct that to remove those algae produced DOC actually is very important. But on the other hand, I'm thinking, why do you even run an algae scrubber? So that's one of the reasons I get rid of all the refugium for several years ago. Everything gone. So I actually using Polyp as my nutrient export. yeah, because the Polyp is a coral.
Sure.
Yeah. And then every 2 weeks or 3 weeks, I will pull out so many zinnia, and then I post on the forum or tell the local fish store owners, say, hey, come here, get it.
Sure.
So that way, that is a coral based nutrient export.
Mm-hmm.
Yeah. And then a local fish will love it. Then one guy actually holding half 5-gallon bucket full of zinnia. He said, "Oh my God!" And that well worth the trip, man. He was selling.
Don't let it get in your display. Don't let it get in your big frag systems or display tank. There, Doug.
That's a risky biofiltration method. But I like it.
There's another nutrient export. It's called the bubble tip anemone.
Yeah.
Because we now all have all these bubble tip is so pesky. They split. I used to have anemone refugium, basically a section of it filled with bubble tip anemone. And then to make it look pretty, I dump in 20 clownfish in it. It looks very pretty. But that the end result is that my phosphate and nitrate just drop to zero quickly. They basically, the bubble tip are so effectively removing phosphate and nitrate. So I have to yank them out. I have to give them away because
they grow like crazy. No, exactly.
They're very effective. Yep.
Been there, done that with bubble tips.
Yeah.
I don't have them anymore. No more for me. I'm good.
No more.
But back to carbon, when I used to grow Gracilaria macroalgae, which some people will put in their tanks, I used to have to use carbon, a lot of carbon when growing macroalgae. Just because of all the metabolites, and it just would be nasty. And then it would just suffer and die. And so once I got carbon on the system, it was a huge change, considering how dirty algae can be. But this isn't high density. This is, we're talking 1,000-liter tanks, with a lot of it in there. So, but yeah, the reactors are interesting when it comes to, algae is growing, it's taking things in, but it's also exuding stuff that might hit a tipping point eventually and start causing some problems. So intermittent carbon could be something like somebody brought up when running those things. So.
Or sponges. We're missing one key element in our reef tanks that are omnipresent on natural reefs, and they're major consumers of DOM. So could be there too. Just using more sponges in our systems would help to reduce the need to use things like activated carbon.
So there several years ago, sorry about that. Sorry.
No, Don, go for it.
Thank you. So there's several years ago, there is actually a scientific paper. They published what they're trying to figure out is that where's all the phosphate goes in the ocean, because they said, well, there's a lot of fish that produce a lot of phosphate, but then in the natural coral reef, phosphate is always like zero. Then that paper described that sponge is the major consumer for phosphate. So that's where the phosphate go. And then they come up with a nutrient cycle and then how important sponge is. Remember Steve Tyree?
Oh, yeah.
Yeah. Tyree used to sell sponge. Yeah, and his cryptic zone is all based on sponge. That was 20 years ago, and he's maybe he's an alien come back from the future, right? So his cryptic zone actually is scientifically valid with all the sponge. Yeah,
I was gonna ask that question because I've heard, Dung, that I used to have a cryptic sump on one of my systems, and I thought it was beneficial because I had a lot more sponges and microfauna and feather dusters, a whole bunch of stuff in that cryptic sump that I thought was augmenting the, it was benefiting the system. But I've also heard the argument that cryptic sumps could be potentially taking away from what the corals could take in. So I don't know if anybody has any opinions on that in terms of, is a cryptic sump something that's beneficial or potentially not beneficial for that reason? Is having more live rock versus less live rock, back when we all started our reef tanks, I think it used to be 2 pounds per gallon in terms of live rock. It was like a brick wall, right? And now it's a lot different. So I guess my question to the panel is, do we need to be concerned with having too much surface area for bacteria to proliferate and potentially taking away from what the corals can take in? Are they taking in valuable bacteria that the corals could be taken in? I don't know if there's any scientific studies out there about that, but or if that's just getting too into the weeds. I don't know.
I mean, as far as a general answer, unfortunately, it's like with a lot of this stuff where, your refugium, no matter whether or not it's cryptic with sponges, whether or not it has macro, whether or not it's xenia, right? It's you're operating it to log. It's going to have this period of growth, and eventually it's going to plateau off, and then eventually there's going to be some point where it chokes itself out, either physically limits the flow, for instance, with sponges, or drops out the nitrates or phosphates. So it's your job as the curator of the system, because it's really be nice to have like Moorish idols, like, trimming all the sponges down there, but scales tough. But as the curator of the system, it's your responsibility to, you're going to have to trim and harvest that excess material in order to modulate the balance that you're desiring. So yes, I think you can let it overgrow. It can probably consume too much stuff, and if the stuff up top is growing, it can get choked out of food if you're feeding the same exact amount over time. I could see that. It probably also choke out the flow, and that probably cause more immediate problems. But yeah, it's all about curating it so you can modulate that log growth. One of the things that I'm really interested from this whole conversation, and I really enjoy the reef aquarium industry for how it gets everyone so excited and thinking about everything as a system, because you think of the same way, and it's how we treat, like, for instance, wastewater. You want to establish the same system in theory for a city, right, where your exudates from humanity are being consumed by some sort of purposeful organism, and then we are curating the take that xenia and you sell it. You make money. You take that macroalgae, you feed it to your urchins if you're me. Like, you find some way to capture that biomass, and then the next phase of a really profound refugium, no matter what's in it, is, what you do with that biomass. Putting it in the trash is probably the easiest but the least expensive. Be expensive.
So I have a question for Ken. So the non-sulfur, purple non-sulfur bacteria. So are they actually mostly living on surface, or actually living in the water column?
Both, actually.
Both.
And on the corals. Yeah. So there's actually a paper, if anyone wants to look it up. Jessica Tout published it. She's, 15 years ago, but they did a survey of heron. I can't remember what island, but I guess that doesn't matter. They selected what they thought was a good model for a healthy reef and looked at the microbiome there, but they broke it down into niches. So there was an open water, there was a sandy substrate, there was one on the corals, maybe a coral mucus and a rock one. I can't remember how many ways they broke it down, but in that case, they found all the 3 genera that we offer in PNS ProBio. There was Rhodospirillum, there was Rhodopseudomonas, there was Rhodobacter, and some other phototrophs in there too, including some really important pelagic cyanobacteria. But those dominated in all those habitats, including the open water. Part of that has to do with the life cycle with a lot of these bacteria. So Rhodosunomus palustris is probably the most interesting one, I guess, because it's just normally occurs like in a rod shape, looks very much like a lot of bacteria, but it forms these things called rosettes. So if you imagine like a guy blowing up the long tubular balloons, you know, in a almost like a star or something like that, and they get bigger, which I guess, you know, for our purposes is kind of cool because it varies the particle size, so to speak. So it offers more feeding opportunities to different types of bacterial grazers. But anyway, that, you know, those rosettes continue to hook up to other rosettes or just proliferate and form biofilms. So they will swim around in the water column. They have the younger stage. They have a flagellum and they swim around, and then at some point they settle and then become mother cells and form biofilms, and then from that they produce more daughter cells, which just swim away and seek new habitat, but a lot of them end up getting grazed by, you know, bacterial planktivores or killed by viruses. But yeah, the water, that's a misconception about a lot of these anaerobic bacteria, especially the facultative types. They do live in the water column sometimes in pretty significant quantities naturally. Yeah.
So is it a possibility to make PNS bacterial reactor?
Yes.
At the sewer treatment of your little reef tank city. So to build a little chamber, whatever things that really suitable for this biofilm to thrive, and then hook it up just like a filter as a part of the reef system. For example, that I watched some of your video, and you mentioned that the PNS bacteria actually really prefer a higher temperature, right? So is it possible to have a little reactor with a lot of surface that the PNS bacteria like to colonize on to form biofilm, but with a slightly elevated temperature versus the rest of the reef?
Sure. Yeah, that's actually been done a few times in the lab. Yeah, these are prototypes. But what's cool is they're like little versions, right? They're probably were meant to be scaled up, but they're perfect for like aquariums. And they're really cool because, yeah, that, you know, they do provide an ideal habitat for these types of bacteria, including near infrared light, which they can actually utilize, but then that excludes the things like that we wouldn't want in there, like algae or, you know, cyanobacteria or whatever. So you can just target, you can grow the target PNSB that you want to grow just by altering the light source like that. And there is I'm not sure where it's going to go. There's a notable figure in our industry who may be working on that right now, as a matter of fact. I will say though, yeah, so I will, but it comes with a caveat, right? The reactors are limited because they're only going to be, we'll say, as compared to like a bottled product, which is like concentrated like crazy. The reactor is only going to churn out a really small amount at a time. Whereas if you feed with a bottle, I mean, I literally, I sometimes I'll turn the water pink. I'll add so much, right? You're not going to see that from a reactor unless your tank is so foul that it wouldn't matter anyway, because these growth media that we grow these on are extremely rich. You don't get those, that amount of, carbon and nutrients in the tank ever at any point. So they're never, my point is a reactor would never be as productive. On the other hand, though, the nice thing about that is that it would be free. Everyone loves free. And also a continuous supply. So it's kind of acting like a doser, right?
Right.
So it's a continuous supply of a known beneficial and known to be benign, never pathogenic type of bacteria that we know corals associate with and feed on. So in those respects, a reactor would be pretty cool. You'd have the initial cost, but then after that, you'd have this source of live food that in order to grow it, actually be using waste products from the tank to produce a nutritionally dense natural live food for your corals and other filter feeders. So no, that's a great thing to point out. And I do think something like that would be great for reef aquarium applications for sure.
Interesting stuff. Hey,
Yeah.
Ken, here's a question for you from Andrew. I think it's a question. Ken, you don't use human probiotic from stomach lactobacillus in these concoctions to feed corals? No evidence they use it, correct?
No. So we specialize in phototrophic bacteria. So I don't do any of those sporiform like bacillus, lactobacillus, and they are really common in the aquarium market. I think the biggest reason is that they're just cheap to obtain from third parties. And whether or not they work, whether or not they're natural is up to debate. And I really mean that, it's up to debate. Some people say they're not present in coral reefs. Bacillus licheniformis, for example, I found that on a reef myself. That would be one of the types of bacteria that he may be referring to, used as a human probiotic. So that's up for debate, but we focus on these types of phototropes that are known probiotics in the coral reef environment, and specifically those types that are highly nutritious. In fact, Deep Cycle, our newest product, actually are reef bacteria that we harvested ourselves, brought back and cultivated. So they're indigenous coral reef organisms. And in fact, the whole group that we collected is self-supporting. So they actually work together in a syntrophic manner. Syntrophic meaning that they just eat each other's waste products. So they recycle nutrients in the sand bed because they're all, or deep in rocks, they're all anaerobic. But they perform a variety of functions. Some are, probiotic, denitrifying, and nitrogen fixing. But certainly, like rhodovolum, the purple non-sulfur in there, is an extremely nutritious bacterium. So, yeah, species like that would be, those are definitely known to be, coral associated and marine organisms. We ourselves found 2 of the 3 species that are in ProBio on the reef doing our own aquabiomic surveys, right? Just from a few sites, we found those 2 species on the, I don't just mean those genera, but those species we found on or very, very near corals, specifically Halides. And yeah, we would never, if I was going to sell human probiotics, I'd sell them to humans. But that market is flooded, and apparently the market for human probiotics in the coral reef industry is also flooded. But as people start to understand what they should be putting in their tanks, is as the availability of certain types of microbes, we have a better selection. People understand their aquabiomics data better, so that those reports become more "quote unquote" actionable. I do believe we will fine tune that stuff a little bit more. You'll see less of the weird terrestrial or human probiotic bacteria kind of just being, pitched in our industry, and more of it will be truly marine and perhaps even coral associated species, in the best case, actually derived from healthy corals in the wild.
That would be a huge step. If you can achieve that, that's for sure. That would be a real revolution. That's for sure.
So I had a question for each of our guest panelists, and we talked about activated carbon, but for each of you guys, what are your thoughts in terms of using ozone and or UV sterilizers?
I don't use either.
You don't use either?
No.
Why, Chad?
I just never felt like I needed to. I make sure I quarantine fish well, and just make sure to stay on top of the tank, and I don't know. I feel like it's just too much, you know. I don't know. I'm a very simple person when it comes to my filtration and my sump and my habits. So I just feel like it's kind of would feel over the top for me.
So if somebody was asking your thoughts in terms of using the Reef Nutrition product line, would your advice basically be don't use UV and don't use ozone to maximize effectiveness, or is there any evidence that it might not impact it terribly?
I would say if it's working for their system, then they should just keep doing that, and then and feed the foods and just keep on trucking, kind of thing.
In terms of if they're using UV, if they're using ozone, then that's fine.
Yeah. Yep.
Okay.
It's another one of those things that you shouldn't not use 24/7. As far as a UV, as far as I'm concerned, for a UV or ozone, in case you have a hick outbreak, I would use a UV sterilizer for sure. Certain part of the infestation, right? But all the time, I'm sure it removes too much of beneficial stuff to run it 24/7. I would not run a UV or a ozone generator. If you have good flow, you're going to keep your O2 level high enough in your tank. Ozone can do that, bring a little bit of oxygenation, but you don't need it 24/7. That's for sure.
Are we too obsessed with water clarity then? People that want to use ozone for water clarity and activated carbon and UV sterilizers. Are we as aquarists getting a little bit too obsessed with water clarity?
It's a compromise.
Yeah.
If you're a curator of a public aquarium and that tank needs to be ready for public viewing, ozone becomes an incredible tool. I think ozone is a little bit of a wild call for the recreational use. It can be a little bit dangerous. I know we're dealing with smaller reactors, but I think these are tools I think should have cause before going ahead and throwing all the money at it. But I think ozone in particular, I'd be a little bit nervous of. I haven't worked with any of these smaller units, but I'd like to make sure that they're safe, because that ozone kind of scares me a little bit. As far as UV, we know that you can choose UV or not. It does affect your microbiome. I think in certain situations, not obviously conducive to a coral reef directly, but the example with the lobster hatchery, it favored Vibrio. The more they cleared the stage, the more Vibrio inevitably was what kind of ate all the broken pieces and then was able to set up shop. That's different in our tanks that have lots of other complicated areas like live rocks. You always have other areas where you have microbes that are able to propagate. But yes, everything affects it, and it cannot necessarily affect it in a universally positive way. So always consider that there is ebb and flow just like everything, but it is not universally beneficial. I'm not willing to say that.
Ken,
So
what do you
yeah,
think?
if I understanding correctly, so basically the what you're saying is that ozone UV basically disrupt the balance of the bacterial biome in the tank.
In this particular study, when it came to the red water system of Rhodomonas, the Archarchatonsa, the copepod, and European lobster larvae, it favored non-long-term selected species. So really opportunistic growth that eventually led to Vibrio, and then you had lower overall more survivalship of the lobster. When they took the UV out and they just did water changes and allowed that initial bacteria to evolve as opposed to being cleared out every time it processed through the filtration, they had less Vibrio in their TCB tests and greater overall survival. That's a very simplified model. It's a very important model for me, for aquaculture. For instance, when it comes to my Berkelhamer systems, when it comes to larvae, I don't do UV. I don't do protein skimmer. If I could, I really wouldn't. I'm not even crazy about it for the adults at this point. UV, really not crazy about it. Skimmer, I use strategically. I don't like to blast all the time. I don't think skimmer's necessarily bad. I like skimmers a lot more than I like UV. I don't think UV is necessarily a great tool when you need it. I wouldn't use it for my larva culture. No way. That water's either ready for larvae or ain't.
Ken, man, what do you think?
I I mean, there could be a place for it in some, you know, applications, like say you're running in a retail environment and you want to quarantine your fish before you sell them, something like that. On the other hand, in a reef tank where we're trying to mimic a natural environment, including the natural bacterial plankton community, it's obviously disruptive. Everybody, you know, everybody knows a lot about this stuff, talks about that. Andrew Bauma talks, you know, works a lot with aquabomics, talks about that a lot, particularly with respect to one really important clade, the Pelagibacter, bacteria that are so important in the wild, and also to corals, specifically as a food, it seems, to actually talk about food here a little bit, but right. Yeah, I think, like, you know, if you're using, why would you be using UV? Generally, if there's something else wrong. So it's almost like the classic example of sweeping something under the rug, or frying with ultraviolet radiation. Same could be said of skimming, though there may be a place for it, where in more moderation, say periodic skimming, say you run it at night to help maintain your pH during lights off cycle. And you know, you can remove, it would be a means of exporting bacterial biomass, and therefore, you know, controlling nutrients, for example. But at the same time, if you have a period where the skimmer is off, they're able to rebound. You know, a lot of these microbes have life cycles as short as, you know, a few hours or short or less. So I think using it intermittently is a lot, without any real evidence of, you know, it's just, it seems that running like you know, UV and ozone and skimming, all these things intermittently seems to make more sense than to run it continuously.
What about to Andrew's question? Does intense UV 200K, 300K microjoules kill your PNS bacteria?
Yeah, that's something we haven't tested. You know, I really don't recommend using UV, so I haven't developed any real protocol there for. We just say, you know, to turn the UV off when you actually dose, if you want the bacteria to live. Now, if you're just using it, if you're using our bacteria solely as a food, and some do, leave the UV on. Who cares? If they whether or not they get irradiated, they're nutritionally the same, and the corals will still eat them. If you're hoping that, though, that the bacteria colonize your tank when you use these products, we just recommend turning the UV and skimmer and any ozone off for an hour or so. That gives these bacteria time to find a suitable anaerobic and presumably protected microhabitat, such as, you know, even just the shallow layers of a sand bed, or getting underneath rocks and stuff where they can at least attach and form biofilms, at which point they're actually safe, more or less, from the UV and the skimming. The ozone, not so much, of course, but that's the best you can do in a system like that. And it's the same for all bacteria, and probably a lot of phytoplankton too. They're a little bit larger, so, you know, UV isn't as lethal to them. But yeah, it's more specific to this question. We don't know what kind of intensity is required to achieve a complete kill at a given rate too. You know, that matters, passing through a skimmer. So we just say turn it off for a little bit, give the bacteria time to settle, give the coral time to graze on them, and then just resume operating the unit after you're done feeding.
I wanted to go back to a question that Tim Johnson had very at the beginning. We didn't get a chance to address it. This is a question that's kind of two parts in terms of when should you be feeding your corals, what time of the day, and then the other part is polyp extension. You know, what role does polyp extension play? Is that saying that, according to Tim's question, is it indicating that they're ready to eat, or they eat? You know, I would say, or is it an indication that they are currently eating? Let's address that first question with you guys on the panel. What would be the recommendation in terms of feeding your corals? What time of the day?
At night. Corals feed at night, basically. And polyp extension is a difficult one in a sense where you can create a polyp extension by adding a product in the tank, right? Getting them ready to feed, or to get anything that's going to go to the water column. But as far as an indication that they are ready to eat, those tentacles can be defensive. They can be anything else than being ready to eat, right? I don't think that they just take their tentacles out because they say, I'm hungry. No. They get it out because there's food in the tank, right?
I'm starving here. I'm looking for whatever,
I'll go McDonald's right away. No, but I think it's not an indication if you haven't feed your tank, or there's nothing to feed on. The tentacle's not going to be an indication that they're ready to feed. If you added some food or some amino acids that can create a polyp extension, you can actually prep them for feeding. That's for sure.
Right. What's the name of your product again that can kind of Polyp booster, right?
Yeah.
Will kind of stimulate the coral to get into that feeding response. Yeah.
I mean, we have people at trade shows which will sometimes come by and grab something from us to stimulate their corals for the show, to kind of wake them up, and
really?
Polyp extension and get them actively feeding. Because like Dong was saying, these are opportunistic feeders. If there's food, they're going to try to get it no matter what time of day. And it probably depends on the kind of coral. Some corals do prefer to feed at night, while others are happy and open and ready to feed all day during the lights on. So yeah, I think that it's people feed at all times of day, and I've seen videos of corals that look like they're actively feeding, and with lights on, everything's rocking and rolling. So
Ken, your thoughts?
Broadly, I would agree with Phil. Corals, I mean, it's just widely known they're mostly active feeding at night. So that would be the best time if that's convenient for the tank. Yeah, it sometimes it doesn't work for the person, but that's where maybe like auto feeders could play a role or something like that. But in the case of our foods, corals do feed throughout the day, and really tiny foods like picoplankton, bacteria, fungi, things like that, tiny phytoplankton, even the smaller protists, they can capture those things in their mucus, so they're not necessarily stinging these little tiny bacteria and harpooning them and pull it. It's a different feeding mechanism. Yep. They have well-developed cilia. They're able to brush those foods that get stuck into their mucus into their mouth, and that's kind of occurs continuously. So the other thing about feeding during the day where I might recommend it is, I didn't think we'd be talking about feeding fish today that much, but there is one really effective way to use our bacteria, and that is as a fish probiotic, right? So it's these bacteria, specifically some of the species we have in them, occur naturally in the fish gut in the wild. There are papers demonstrating that. They live and are dispersed throughout the environment, sometimes even from rivers to marine environments through fish feces even. So these bacteria remain viable even after they're released with the fish waste. So this speaks a little bit, maybe to what Dong was saying earlier. Maybe a matter of controlling what your fish eat, making sure that nutritionally enriching their poop, so to speak, by
not at all.
By maintaining a healthy microbiome as opposed to a disrupted one, where they might be spreading pathogens, right? So all that being said, there's a lot of evidence in the scientific literature showing that cultured fish benefit from larval stages all the way up, growth performance, disease resistance. They benefit from these particular types of bacteria in their diet. Some crustaceans as well. But if you put it in their food, it does survive in their gut. It'll increase feed conversion, so the animal digests more, and therefore it produces less waste. So that right there is kind of a form of filtration in a weird way, because the fish are producing less waste. But then the fish they do produce, the waste that the fish does produce is actually enriched somewhat nutritionally. And it may actually, because these tend to inhibit pathogens within the fish gut, that may make it a safer form of fish poop food. So we recommend putting it in fish foods, so you can actually soak it. And getting back to saying during the day when most people feed their fish and the lights are on and so forth, you could actually just put our bacteria into like even a pellet or something like that, a dry coral food, reefroids, something like that. Even soak it in there, and then give it a minute to kind of get into the food or whatever. That's not an exact science. You can use it, experiment with binders or whatever, but the idea is just to get a little bit of the bacteria on the food. When the fish eat it, they ingest it, and then the bacteria live that way. So that's a weird take on whether you should feed it during this particular product during the day or night. But it's more, I mean, you can actually work it into your feeding schedule and your habits, your daily habits. If you're chopping up all these frozen foods and all, even just for your fish and corals, it's something you could just add to the mixture then and there, and it'll get through the fish gut. Some of it will just get released right into the water anyway, but that's okay too. Things can feed on that. But
corals, big mouth corals, is one of the most spectacular vision in nature that I was fortunate enough to see with speeding those. This is incredible. So yeah, I would maybe feed it with light so I can see it.
Yeah.
Hey, Ken, you mentioned pathogens, and I think we know that there seems to be evidence that pathogens can hitchhike onto coral and fish food.
Oh yeah.
What are best practices to try to avoid that?
Antibiotics, if that's a bad word, right? Or you can use probiotics, organisms that nutritionally enrich things, even like live foods, that produce their own antibiotics that compete with known pathogens like Vibrio, that tend to be, even undecapsulated brine shrimp cysts are known to be vectors for a lot of pathogens. So there is one study actually where they use Rhodopseudomonas palustris in a hatchery with a variety of live foods. There's a copepod, I believe it was Panamensis. There were your garden variety rotifers. There was a cladoceran like Moena, and then there was another one, but in that case they saw that it actually was in the live food gut, and that when these gut loaded feeds were offered to larval fish, it actually reduced the incidence of disease. So whether or not these bacteria survive when they're in the animal's gut after they're consumed by that intermediate, in our brine shrimp or whatever, either by being alive or just having the antibiotics present actually does inhibit disease. Yeah, we see that a lot. Taras brought up shrimp. These bacteria practically saved the Pacific white shrimp industry. That too was a Vibrio. These were shown repeatedly to inhibit Vibrio, both in the petri dish, but also practically in the hatchery, and significantly reduce mortality in cultured shrimp due to the control of a very particular disease. So absolutely, I'm sure Chad could speak to this too. There are even some phytoplankton that have antibacterial properties that I think those things are underexplored, but that's one of the benefits of using live or at least whole cell diets for animals like these, for sure. It's just the disease prevention is definitely overlooked.
It's a great place to be able to look towards commercial aquaculture with shrimp hatcheries, and then in the past I did oyster hatcheries, where you're right, these are massive industries where they have massive examples of a single species being fed these same species we're working with, these same live foods, the same rotifers, Branchionis plicatillus, Artemia, Tiastochryses, the same algae and the like, and these are larvae that cannot handle very small amounts of Vibrio coriolyticus entering the system and having conditions that allow it to go pathogenic. Because of that, there is you can't use antibiotics on these larvae, and you can't use antibiotics on the ones that they're going to use to feed the people. So the studies, the funding that's coming out of these direct probiotic products that are being tested on a mass industrial farming scale, it's very interesting and it could be very rewarding for us because it is the same Vibrios and the same similar set of at least pathogenic bacteria. Of course, there's also the entire marine aquaculture industry that deals with ick in the nursery stage, cryptocaryon and velvet. So God knows they can't be dosing everything with copper with those larvae. So there's all vested interest in dealing with the same set of generalist pests that we deal with, especially with fish and inverts. So there's a lot that we can benefit from sharing and receiving information from the commercial aquaculture sector.
Mm-hmm.
I'm sure Chad can speak to that because you guys really do kind of merge the groups there with Reed.
Yeah, absolutely. Yeah. And it's been ongoing for decades, this whole probiotic improving the gut of fish. And, you're going to be improving the gut of corals too with this stuff, I'm sure. And so it's really good to hear that there's some success being had, finally drilling down deep enough to find some success. It's very positive to hear. I can't wait to pass some of this on to some of my connections in aquaculture. So yeah, appreciate this. I'll be reaching out to some of you.
Anytime. Always love our chats, Chad.
Well, Chad, that means that you guys can have a new product line that have those pellets or the TDO. Is a probiotic infused TDO.
Right. Yeah. And maybe we incorporate some of these things into our live animal cultures, the rotifer cultures, the copepod cultures. Because, not just like you said for the gut flora, but also it's something that could improve the culture itself for water quality and things and outcompeting other nuisance bacteria and the like. So it's always something I'm thinking about is, when I set up a new culture with copepods and get it going, I'm like, I just started this thing sterile. What could I put in it immediately to kind of activate it and get it going? Because some of my cultures don't live that long. They, they exist for 14 days and then everything gets harvested. And so in that 14 days, if I can do things to that little ecosystem that will improve it rapidly and help them grow better and faster and come out nutritional and less susceptible to stress and shipping and whatnot, I'm all for it. So I'm excited. I got some experimentation ideas zipping into my brain right now. So.
Well, my brain is definitely overloaded from tonight. I mean, everybody's got my wheels turning. Dong, I know you had some other questions. Did we get to everything you wanted to talk about or at least ask about?
That's what I'm very fascinated about the PNS, the purple non-sulfur bacterial. So actually, here's a question for Ken. So the purple non-sulfur bacterial actually has been quite popular in the freshwater world, right? Because the freshwater people has been growing them at home. So are they the similar species or actually different species from the saltwater one?
In some cases, it's the same species. I'm not sure about strain. Our strain is Euryhaline. They originate from salt flats. specifically on the case of and on the coast of Massachusetts. So they're adapted. Yeah, they can handle salinities that exceeds the salinity of seawater. So that's not an issue for them. But they can also live in, just straight seawater. Salt, they just don't require salt to live. It doesn't harm them. Definitely a lot of freshwater applications for sure, both with fish and plants.
So yes, I see that Brite Aquatic, they come up with a purple M, right? So that is the purple non-sulfur bacterial. Is that right?
I'd say test it.
Because it seems like everybody is going after the purple non-sulfur bacteria these days. And I even see there's a manufacturer in China. They were producing this in bulk. So that's what I'm thinking about. That maybe maybe she should really look into that to see if there actually is the right kind for this. And well, not all, but basically there are so many different purple non-sulfur bacteria out there, and it can be very confusing. And so if people add the wrong one or the not very effective one, it can be harmful, or at least polluting the tank. If there's a wrong type, would that be a possibility?
No, there are no known purple non-sulfur bacteria. No known pathogenic purple non-sulfur bacteria, actually. So
basically, all of them are okay to use.
Oh, sure. If they don't survive in the tank, I mean, their best use is always going to be as a food anyway.
Okay.
Whether or not they live is, I mean, if they do live and they perform some denitrification or degrade some DOM or remove some phosphate, those are really just side benefits. But the like the ones we were speaking of, the probiotic ones, if they live on a host, then those are much bigger benefits. But even so, in my opinion, the biggest benefit to a coral reef aquarist using these bacteria is as a food, for sure. All of our strains, my Rhodopseudomonas, so like I mentioned, Rhodopseudomonas palustris is kind of the one that everybody knows about, talks about. There are a lot of different strains, and they vary quite a bit in salt tolerance. Ours TIE1, you can actually, it's probably after the type species, that's the most widely researched one. So you can get a lot of information about that one. But we've actually grown all of our bacteria in saltwater before. We used to have a product where they were cultivated in saltwater as a mix. So that's not really an issue. And then, like I said, the deep cycle, those are actually marine bacteria. Those were taken from a marine environment. So clearly those are saltwater strains. Not just the purple,
I do have
sulfur, but the purple bacteria, the purple
non-sulfur.
And that one that has a purple sulfur and it has a green sulfur in it as well.
Right.
But yeah, of course they're all marine because they came in the same little pinch of sand from French Polynesia.
I do have a question from one of my customers. So he asked, can you actually infuse the purple non-sulfur bacterial into his deep sand bed? And because that purple non-sulfur bacteria is oxygen, they like the oxygen poor environment, and they do best under there. So is it a possibility, because he has a deep sand bed and he got yelled at by all the fellow reefers, so you shouldn't have that, dig it out, whatever. Then the thing is, he asked, is it possible to get some kind of tubing and poke underneath his sand bed and pour the purple non-sulfur bacteria, let it infuse at the bottom layer and make it beneficial?
Yeah, people have done that.
Oh, good.
Yeah, just with like a little syringe or something, and you can put a piece of airline tubing or something and inject it into the sand bed. Now with ProBio, which has 3 species of purple non-sulfurs, the purple non-sulfurs are very facultative. They live and reproduce quite easily in aerobic environments. And that's just been demonstrated in the wild over and over again. That's not an issue for them. And in that case, they're actually, they're not relying on photosynthesis, so they can grow 24 hours a day and not just 12 hours a day or whatever. Growth rate may not be as high, but it's constant, right?
So will that be a revolutionized deep sand bed again to make it cool again?
I think the other product definitely more so. And I know it's a discussion about food here. I don't want to get too deep into Deep Cycle, but Deep Cycle is the one where we got the microbes from the wild, right? And that's a mixture of different types of bacteria. And some of them are obligate anaerobes. So that is the one we really recommend to inject, because you're going to expect a more successful rate of colonization if you put them directly into the more suitable habitat, right? So that's the one that we would actually recommend injecting into a sand bed. And for sure. But what is it? I don't know what the thing about sand beds is that everybody dislikes so much. There's always this talk about sulfides. And it's
because deep sand bed is not cool anymore.
Yeah, I guess. So they get pissed when it's blowing all over their.
I was thinking about somebody shaking the sand bed and putting bacteria in it. Then the tank is finished.
Yeah, so make the deep sand bed cool again.
Yeah.
Right? No, a lot of people, Jake Adams famously hated any kind of sand or. Yeah. If you remember the studio from back when he operated it, it was pretty sparse in terms of rock even. And he really didn't care. Some of his corals were just on like bricks and shit. It's kind of hilarious. Like it was more like at least those big open flat systems were more, it was almost like a gallery, right? Of just looking at corals, this collection. Definitely though, he hated sand. He thought it would be dirty. Didn't like all that. But he was using our stuff around the time he had passed, and I had an opportunity to get into the studio and collect some samples for aquabiomics data, and we did find Rhodopseudomonas palustris living in that system. Okay. Right, and this is months later, well past the usual life cycle of any kind of bacterium, right? So clearly they were either living in, there was enough anaerobic area just in the little tiny microscopic cracks and crevices here and there on the corals, because these bacteria do live on and even in corals. So it could have come from there, and it may not even been from my product. It could have came in from the wild or something, but that's irrelevant. The fact is, I know nobody had done anything in that system for a few months, and these bacteria were still living in that system, which is like the poster child for like an anti-sand bed kind of tank. So certainly these bacteria are awesome for sand beds, but they'll live in even a bare bottom tank, and you'll see benefits because there are always anaerobic spaces inside of even the most sparse and sparse tanks with the strongest water circulation. Right. So
that's wonderful. Actually, you should market it special package saying this is make the deep sand bed cool again package.
that's
seriously.
That's Deep Cycle.
Yeah. So
there you go.
Then you should make the logo there to make, because I frequently run into people and he said, "Can I have a sand bed?" I said, "Why you cannot have a sand bed?" I said, "If I have a sand bed, I post on the form, and then 10 people will yell at me, and 100 people will just hate on me." So then they said, "Well, yeah, you can have a sand bed, and if you like the look of it, but right now, but now then, if there's a product that can make the deep sand bed cool again, that will really change the thing." But now I have another question from a customer for Phil. Actually, also somehow related to Ken's bacteria too. So the Polyp Lab does have some kind of media, right? You do sell some kind of ceramic or whatever media.
Ceramic media.
Yeah,
ceramic media, is that right?
Yeah, but it's not on the topic of food. That's why I was not talking about it. But we do sell ceramic blocks that are adding a large surface area because of the bees that are really small round beads into a rectangular form in which we place into a support that can be set up in an aerobic setup or as an aerobic setup as well. They can be stacked up together and offer the large surface area for bacteria to grow and create biofilms, right? Remove nitrates or reduce nitrates, reduce phosphate, and also as a help for bacteria to colonize. They don't get brittle. They don't fall apart, and you can easily remove excess biofilms by just removing a little bit or put under water and put one of the brick in. There's 4 bricks and 1 support, but yeah, that's a product we have. But
So the question is that can he use that as a substrate to line the bottom of the tank?
Well, yeah, but it's not nice.
Well, it look better than the bare bottom reflection.
no, but I mean, there needs, of course, technically.
So can you make like a sand media, sand material, but in a large balls like coarse sand?
But it
to
exists
make
already. They have biomedia that exist, and
Just take a hammer to it, Dung.
Well, people normally don't touch hammers because the hammer has metal.
No, outside of the tank, for crying out loud.
some customers or some we have customers in California that brings the rock 100 at a time without the support, only the ceramic rock. And his idea is that his system as a microfauna in which he puts the rock inside, and he starts new customers' tanks with a few rocks in them. I have no paper whatsoever that it's something that works. But I mean, we know it works with bacterial products. With our Genesis, for example, we have biofilm forming, and I'm sure Hydrospace products would form biofilms very easily. As far as I know, bring back the sand bed popular again. People like to have clean or not clean, neat aquariums. The way that you can stack those rocks, you can place them in very smaller area. That's one other thing about aquariums. We're no longer in those 6 feet, 10 feet aquariums or even 4 feet aquariums as an average tank today. We're more on the lower, on smaller tanks, so the space reduced. So you need to find options to create surface area that's going to be suitable for bacterial products and for products that's going to help reduce nutriment and help grow coral.
So how about this idea? So using this Genesis block, line the bottom of the tank and then put sand on it, and then you infuse the PNS bacteria on the block at the bottom.
Yeah, sure. Everything goes, right? Sure.
So the reason for that
who
is
needs bare bottom when you got that kind of, or who needs sand bed when you got that bare bottom tank going there?
It's
right, sorry for that.
Taste.
What's that?
Yeah, go ahead.
It's a question of taste. I mean, I like bare bottom tanks. I like it when it's bare.
So that
just in the sump, you could have a sand bed in the sump.
Yeah.
The cryptic sump. Thanks to Keith to have. I learned something today about that. I didn't know what a cryptic sump was, but I knew in French, not in English. But at the end of the day, you could do the sand beds in another area of the sump or somewhere. That it's not, and then the water's moving. I guess it's possible, but in a tank, yeah, I like it bare.
Me too.
So there was a remote deep sand bed in the bucket. That is a thing. Now we can do a remote Genesis blocks stacked together in a bucket remotely and infused with PNS bacteria.
There's your bioreactor, Don.
Yeah, exactly. That actually that can be a good thing, right? So get a stack of the blocks, infused with PNS bacteria, and put it remote in the sump.
The new product ideas are just rolling out of here, you know. I mean,
yeah, exactly.
Giving a
So
lot of purchased idea.
I want to be cognizant of everybody's time. I know we've gone over 2 hours in this live stream. I wanted to make sure that one question did get answered because Andrew has been chomping at the bit to get this question answered by Taras. And that, Taras, is the question about UV and having UV and whether or not that, would have more Vibrio in a tank with UV versus a non-UV tank. Like, I don't know what phage death means, but I'm assuming you know what that's all about. So basically what he's asking is if I suspect Vibrio in the tanks, are you recommending that he turns the UV off?
No, what I was saying is not a general recommendation in the context of a reef aquarium. This is one specific example that I saw in a simplified environment where you only had a few bigger organisms there. Now, the best way I can kind of describe what they might have been suggesting is kind of like clearing off a parking lot. You clear off a forest and you make a parking lot. You get weeds, right? You literally get weeds. You get the opportunistic critters that are tough for their own reasons, but for X, Y, and Z, it's usually the tough things, and they're usually what's not desired. When we landscape, it's usually not with the toughest stuff. It's usually not with weeds. So I would say the UV is like trimming a forest, applying pressure. If the forest is like a reef tank where there's really lots of reservoirs outside of the water column, let alone the water column that's average going through that particular UV unit. If you're trimming some of the foliage, you still have a forest. Turning the UV on or off, you can certainly, you could add some, especially for your system, it would have to be the size of like a bunch of cars. To go overboard to even try and sway that. What I'm saying is that when starting the system off, if we have to go into the reef tank context, when starting the system off, there may be a benefit for not starting off with the UV because you might, depending on what rock you brought in initially and what initial microbes got brought over from that first set of organisms, you might be dealing with a juvenile forest or you might be dealing with a parking lot. What they suggested was that when they intentionally made a parking lot and they ran the UV versus not, after 4 weeks, they ended up with a parking lot versus eventually a meadow formed, and that they had higher survival with the meadow forming with the lobsters than when they applied the UV, quote unquote, cleaning the system continuously. In fact, what they did was only support the weeds. And in this case, the weeds were opportunistic bacteria that messed up the lobster larvae. So I think when starting off the aquarium, especially now that we have less and less wild live rock coming into the system initially, with more and more dry rock systems getting established, depending on what the proportion is of old rock you brought in from another system, I think that's where it becomes a little bit more applicable. But in your system, for how large and how complex it is and the fact that it's nowhere near getting off, I don't think it's I don't think it's going to necessarily be the great big swayer, especially at the scale you're talking about with your UV. It's more so a smaller system and definitely a newer system and a less complex system too. The second you add even one piece of live rock, I'd argue you're already dealing with a meadow.
Awesome. Thanks.
And not all Vibrio are bad. The Vibrio has there's so many of them. And also the bacteria is like that. They have something called quorum sensing. Basically, one bacteria always suppress the other one.
Yes.
And then some bacteria is absent. The other one will grow uncontrollably and become pathogenic.
Yes.
So, basically selectively killing some probably is not the best idea. So unless there's a reason to kill them. If you have fish has a certain bacterial infection, you selectively kill that type. Of course, it's pretty difficult to do to begin with, because most antibiotic is broad spectrum. And I think that what Andrew meant for the phage is that those the macrophage that actually selectively eat certain bacteria. So I think those also get killed by UV too.
It's a fascinating question when it comes to bacterial viruses, but that's another important thing. It's like, did it kill everything and only the Vibrio survived, or is it the fact that everything was injured? The Vibrio is like, hey, I can take this thing over. everyone's injured. I'm gonna
Yeah, exactly. Yeah, yeah. So
Opportunistic.
like, you know, Vibrio might be fine as part of a general ensemble, but the second the show just turns to Joey, it's no good.
yeah, and then if you wipe out all the video, and then something else will take over because that they're they're opportunistic, right? Hey, I can take over the world, and yeah. So I think that's why that I always against dosing antibiotic. It basically mess up the whole balance inside. Yeah.
Yeah. Well, listen, guys, this was a fascinating discussion. In fact, I think I'm going to have to go back and replay it and listen to it again because there was so much information on this live stream that I think it's worthwhile going back and re-listening to it. So I want to thank you all for taking the time to join us tonight, and we really appreciate all the knowledge that you have shared. I think we're all it's a great hobby, and there's a lot of information out there, and I think a lot of it's got to be kind of taken in and digested, but it's all good stuff. So thanks, folks.
I had a great time.
Thank you.
People.
For having us.
Bye, everyone.
Thank you.
Well, that's going to do it for the show tonight. I want to thank our panel, and I also want to thank our sponsors one more time. Polo Reef. Make sure to check out Polo Reef's latest YouTube videos. Go behind the scenes with a day in the life at Polo Reef. See massive water changes, ICP testing, and giant pumps, plus lots of coral shipments packed with massive acro colonies and the excitement of new rare fish arrivals, including a dragon pipefish and a groundbreaking newly discovered species delivered for the first time ever in captivity. Make sure to subscribe to the YouTube channel at Polo Reef for video drop notifications. Champion lighting and supply. Flow is very important for keeping corals happy in a reef. Growing corals can block flow from wave makers and create dead spots. That's about to change. The ocean sea wave will oscillate any wave maker or power head in your aquarium from 0 to 180 degrees at an adjustable speed. This creates natural dynamic flow patterns, reduces dead spots, and kicks up detritus. The ocean sea wave is available exclusively through Champion Lighting and Supply. Visit championlighting.com for more information. Big thank you to Paul, who's also the moderator, as well as the president of the Boston Reefers Society. Also, thanks to Greg Carroll. I saw him in the chat. He's also one of our moderators, and he's also the president. I always forget the name of the Southern California Marine Aquarium Society. I believe that's he's president of that club. Anyway, please join and support your local reefing clubs. They are so important to this hobby. Also want to let you know that all episodes of Rappin With ReefBum are available as podcasts on Spotify, Apple Podcasts, Google Podcasts, Stitcher, and Amazon. Our next Rappin With ReefBum live stream will be on Tuesday, September 16th at 7 p.m. Eastern Standard Time. It's always the third Tuesday of every month. We're going to be going down under. We're going to be talking about reef keeping in Australia. Our guests will be Anya Narowski from Gallery Aquatica, Shane Danger Coleman from Sustainable Reefs, and Sam Parker from Parker's Reef. Until then, be safe and be well. Later.
Thank you.